Okay guys, as promised, here is your second semester final review. Just a couple things you need to know for the test. Everything on the test is going to be proficiency level, so we're right here, except for the trig part. So that's the Unit 7 stuff that we'll get to at the end. That will have the highly proficient availability, because that'll be your second round of that test. You will be allowed one sheet of notes, 8.5 by 11, handwritten on both sides. I would highly recommend that you try to fit a unit circle on there somewhere. Other parts of the test are going to be rather difficult. The unit circle test, where you fill in the blank unit circle test, is the only part that you'll have no notes and no calculator, but you can use that sheet on the rest of your test. And then just a heads up, reminder for the 500th time, Friday morning at 7:30 is your last opportunity to retake any highly proficients to make sure you have the A or B that you want for the semester. After that, most you can get your grade up to is a C. All right, starting in, first off, finding the solution by graphing. So what you're really just looking for here is the point where these two graphs meet. The first one, x plus 6, that is linear. So that one has a y-intercept of 6 and a slope of 1 because of the just x with no coefficient is just a 1. So I'm going to go up 1 and over 1 as carefully as I can without having a ruler. If I were on a sheet of paper, I would totally use a ruler for this, but now I'm just giving you a squiggly line. The second equation, because of that little booger there, is a parabola. And that parabola has a vertex of -3 because of the x minus h, and -3. So the point -3 is right there. Because it's a regular parabola, no change in A. I'm going to up 1 and out 1 in both directions, up 1 and out 1 and up 3, then out 1 and up 5, doubling up that circle, or that point right there, and then making the parabola. Now, important thing to note, I am not done at this point. All I've done is graph two things. What I do need to do is write my solution points, which are right here and right here. So those 2 points are -5, 1 and 0, 6. So a couple things you may want to add to this. One, like in terms of your notes, what you may want to have on there is that you're looking for the points of intersection. You may want to have your parent graphs on there, at least the equations, so you know what type of equations, telling you which type of graph to use. So that just depends on how much you're comfortable with. Finding the solution to a quadratic algebraically. Anytime we've got x squareds and x's and they cannot be isolated, we need to use either the quadratic formula or factoring, which means we need to get everything over to one side equal to 0. So I don't want to have a negative x squared, so I'm going to add x squared to both sides. And then I also want to get rid of that 4, so I'm going to subtract 4. I'm going to put the -4 over here because it can't be combined with either the x squared or the 2x. So what I have now is 0 equals x squared plus x squared is that part right there, 2x squared plus 2x minus 4. And there's my full quadratic. Now, the things you may want to have in your notes. Depends on how you want to do a problem like this. Quadratic formula may be useful depending on whether you want that method or not. So -b plus or minus the square root of b squared minus 4ac all divided by 2a. That will give you your answers for x. Otherwise, you can factor this and solve from there. If you factor, I would recommend looking for a greatest common factor first. All three of these terms are divisible by 2, so I'm going to rewrite this as 2 times x squared plus x minus 2. The rest of that factors to x minus 1 times x plus 2. So I set each of these factors to 0, so x minus 1 equals 0, x plus 2 equals 0, and I have x equals 1 and x equals negative 2. It's one way to go about it. Some people would just go straight from this place right here and use the box and diamond. That will work as well. If you do everything correctly, you should end up with the same thing. The other method, of course, is the quadratic formula. So quadratic formula, I need those three values. So a equals 2, b equals 2, and c equals negative 4. Just clarifying, you don't have to use both of these methods. You only need to use one of them. Either one will work. Just scooting this over a little bit. All right, so x equals negative b. Our b value is 2. Plus or minus square root of 2 squared minus 4 times a, which is 2, and c, which is negative 4. All divided by 2a, which is 2. So then I want to take everything under that square root sign, everything here, and simplify it. Got x equals negative 2 plus or minus the square root of 2 squared is 4. Negative 4 times 2 is negative 8 times negative 4 is a positive 32. So that's going to be plus 32. Just kidding. Plus 32. So I'm going to go ahead and write that as 36. Just so I don't run out of too much space here. So, and then that's all divided by 4. I want to simplify that further by taking the square root of 36. So we've got negative 2 plus or minus 6, all divided by 4. That's where we split it into our positive and our negative. So do negative 2 plus 6, all divided by 4. Negative 2 plus 6 is 4. 4 divided by 4 is 1. That is one of our answers. The other one, I do negative 2 minus 6, all divided by 4. Negative 2 minus 6 is negative 8. Negative 8 divided by 4 is negative 2. That should come as no surprise since we got, over here we've got 1 and negative 2 for our answers as well. So regardless of which method you use, factoring or quadratic formula, and I did not show you the entire box and diamond. You got to go back to 5A2, that video, if you want to see that entire process. So that's it for those two. So sum up things that I would add to your notes from this. Parent graph stuff from way back when. Make sure you know you're looking for the places where they cross. Sorry. 5A2, probably want quadratic formula. You may want to make a note that you need to get everything to one side equaling 0. And you can also solve by factoring. So those are some things you should add to your notes. Make sure you recognize something like this has to equal 0 in order to solve that. You can't just take the square root to get rid of that unless you only have an x squared. All right, next up we have absolute value. So absolute value, stuff to keep in mind. First thing you need to do, this is what I would add to your notes. So things I'm saying are the things that I would add to your notes. First thing you need to do is to get the absolute value sign alone, the symbol alone. So get everything in the grouping symbol alone. So you want this part right here. You want that all by itself. So the things you need to get rid of are the 6 and the 3. Anytime you are working with the order of operations or you're solving, so parentheses or grouping symbols, exponents, multiplication and division, addition and subtraction, whenever you're evaluating or solving, you go that way with the order of operations. When you are, I don't know what I just said. I think I just said the wrong thing. So let me say that again. When you are evaluating, so just plugging in a number and doing the math, order of operations, you go that direction. When you are solving or finding an inverse or trying to isolate something, you're basically undoing those operations from the bottom up. So you're using those inverse operations to get rid of things. So the first thing that I need to get rid of is any addition or subtraction. So I'm going to get rid of that 6. So minus 6 from both sides. So we've got 3 times the absolute value of x minus 5 equals 12 minus 6 gave me 6. So then the next thing I need to get rid of is multiplication or division, which means I need to get rid of that 3. Currently I'm multiplying it, which means I'm going to divide both sides by 3 to get rid of it. So then I have the absolute value of x minus 5 equals 2. So that's where you need to understand what absolute value means. If I have the absolute value of 2, then that equals 2. If I have the absolute value of negative 2, then that equals 2. So if I have the absolute value of x and I know it equals 2, then what's in there can either equal a positive 2 or a negative 2. That's if that's the only thing in there. What I do have in there right now is x plus 5. So once I have my absolute value isolated, I need to split that into a positive version and a negative version. So I'm going to have x plus 5, just kidding, x minus 5. Sorry if I keep saying the wrong things on these. I'm very tired. X minus 5 equals 2, and then I have x minus 5 equals negative 2. I want you to note a couple of things here. This part of the equation does not change. That's what's in the absolute value. What's over here can either equal 2 or negative 2, because what's inside the absolute value can equal 2 to come out as 2, or it can equal negative 2 to come out as 2. So we set them both equal to figure out what x can be. So add 5 to both sides. So x equals 7, and x equals 3. Proficiency level, we're not worrying about extraneous answers here, because when it only equals a number as opposed to having another x on the side, other side of the equation, we're not going to have extraneous answers for that. So, summing up, again, things you should put in your notes. Get the grouping symbol alone and undo the order of operations. So get rid of addition and subtraction, get rid of multiplication and division, get rid of any exponents, and then deal with the parentheses. So when you're solving, bottom up. All right. Same thing with the radical. First thing we need to get rid of is that 5. So subtract 5, because we're again trying to get the grouping symbols alone. So x minus 4 equals 3. Next thing I need to do is undo that square root by squaring both sides. When I do that on this side, this is the square root of x minus 4. This x minus 4 is a little chunk in and of itself. So when I square it, all I'm left with is the x minus 4. Then I need to square 3, which gives me 9. Add 4 to both sides, and I have x equals 13. That is it for that. That on a number line. Whoops. Next up we have inequalities. Something that you should add to your notes with inequalities. Basically, let me switch colors real quick. Solve it like you would an equation. but you have to remember to flip the sign if you divide or multiply it by negative. That took a long time to write. This video is going to be forever long because of this, but remember, when I keep saying these things that you should write down, please write those down in your notes. It will be helpful later. Okay, so once again, remember, I need to get rid of things backwards when I'm solving. So there's a few ways you can do this one. You can distribute and all that, but I'm just going to get rid of everything. So I'm going to subtract 10 from both sides. Got 50 is less than or equal to negative 4 times x minus 3. You could either distribute the negative 4 here if you wanted to. I'm going to go ahead and just get rid of it by dividing. Notice here that I divided by negative 4. So 50 divided by negative 4 is negative 12.5, or negative 12.5. And I'm going to take that sign and I'm going to flip it. It's currently less than or equal to. I'm going to make it greater than or equal to. And then on the other side, I've just got the x minus 3 left. Add 3 to both sides. So I've got negative 9.5 is greater than or equal to x. The other thing that I did not add into these instructions up here is that you need to be able to put it on a number line. The main reason there is I need to know you know what an inequality says. So this is saying that negative 9.5 is greater than or equal to x. If you look at that the other way, x is less than or equal to negative 9.5. So let's try that again. When I put that on a number line, I need 0, and I need my number. Negative 9.5, clearly less than 0. I don't need to put all the details in the rest of it. I need to remember that I need a solid circle at 9.5 because this is less than or equal to. And that if x is less than or equal to negative 9.5, sorry again, it's going to be everything down here. So that's my answer for that one. Over to a system of inequalities. Again, you're going to need, you may want, if you don't have them memorized, your parent graphs on your sheet of notes somewhere. That one's a parabola. And that one is an absolute value. So, parabola has a vertex of 3, 2. So positive 3, 2. Make my points. Out 1, up 1, out 1, up 3. This is less than, and it's not less than or equal to, so I need this to be a dashed line. And because this is saying y is less than, then I'm shading everything below my parabola. In other words, everything outside of it. I use a different color for my absolute value. That absolute value has a vertex of 5, negative 4. Why do I suddenly have the sense that I did this wrong on my key? Anyway, out 1 and up 1 in both directions. And since this is y is greater than, then I'm shading everything up. Okay, so I'm going to shade again all the parts that double shaded. So all the space in here. or where all of my solutions can happen. So the other part to this is you need to test a point in the solution region. That means you need to test it in both the original parabola equation and the absolute value. So you can pick any point in this double shaded region. I am going to go with, I think, probably go something that's got a 0 here. So let's go with 0, 4. So this point right there, do it in green. That point right there. I'm going to test 0, 4. So that means I'm going to put 0 in for x and 4 in for y and make sure it makes that whole thing true. In the parabola, 0 is less than, just kidding, try that again. 4 is less than 0 minus 3 squared plus 2. 0 minus 3 is negative 3. Negative 3 squared is a positive 9. Less 2. So 4 is certainly less than 11. That one is true. In the absolute value, 4 is greater than or equal to absolute value of 0 minus 5 minus 4. 4 is greater than or equal to the absolute value of negative 5 minus 4. Absolute value of negative 5 is 5, so 4 is greater than 5 minus 4, and 4 is greater than 1. So that one is also true. So that is what I mean by testing a point in your solution region. Specify what the point is. It should be in this part that's shaded by both, and then you need to test it in both equations. Again, things you might want to add to your notes. All right, graph the original and its inverse, and then write the equation for the inverse. The first one, this is my screw up. 1/2 x plus 8. We start at 8. Go up 1. Oh, nope, not up 1 because of that negative. We're going to go down 1 and over 2, down 1 and over 2. I'm going to very carefully, actually I'm going to do a few more dots here because I don't have a ruler. Okay. So there's my original line. I'm going to list a couple of those points. And I'm going to erase that in a second. But I have the point 0, 8, 2, 7, and 4, 6. For my inverse, let me erase those. I'm going to switch all those. So 0, 8 becomes 8, 0, 2, 7 becomes 7, 2, and 4, 6 becomes 6, 4. I graph those points. 6, 4, 7, 2, and 8, 0. This pattern, going by 2s. Your inverse, once you get it graphed, should always be symmetric across this diagonal line, the y equals x line. If it's not, you got something wrong going on. And oftentimes it has to do with negatives because people want to just get rid of negatives for some reason. Okay, so now the equation for this. This is my screw up. You can't actually see where your y-intercept would be. You'd have to go back a ways. What I'm going to do is find it algebraically. So if I've got x equals negative 1/2 y plus 8, subtract 8, x minus 8 equals negative 1/2 y, multiply that by negative 2 to get rid of the negative 1/2. Ugh. I don't know what I just did. Sorry. So that goes So my inverse equation is negative 2 times x minus 8. You can also write that as negative 2x plus 16. As I said, again, on your actual test, when it's your inverse, you should be able to tell from the graph what your y-intercept is, but this is the way you can find it, which I'm going to do over here. So, thing to remember on this part, graph your original, switch all your x and y's, graph your inverse, and then find the equation for it. Over here, I'm tired, sorry. Okay, so once again, parentheses, exponents, multiplication and division, addition and subtraction. When you are evaluating, start with parentheses, end with addition or subtraction. When you're finding the inverse, do everything in the opposite direction. So you inverse all of those operations and you start at the bottom and go up. So I'm going to show you both ways of doing this because, you know, this video isn't long enough already. One of them is to list what is happening to x. So there's my x. The first thing that is happening to x is I am subtracting 4. In the order of operations, once I've done that part, the next thing I need to do is to square it. Then I would multiply it by the 2. And then subtract 6. I'm just shorthanding that. Now, this is what's happening to x. If I inverse that, I'm going to go from the bottom to the top. So this would include adding 6, dividing by 2, square rooting, and then instead of subtracting 4, adding 4. So this is basically from the bottom to the top. These are my instructions for what to do to x in the inverse. So I start with x, I add 6, divide everything there by 2. So done with that, done with that. Then I'm going to square root everything there, and then I'm going to add 4. So that's my inverse. That's one method. I'm going to go ahead and erase that and show you the other method, which is simply just switching x and y and solving for y. Some people struggle with that more than others because you're not finding a number, you're finding a new equation. So I have, remember f of x is just y, so I'm going to swap x and y. So I've got y equals 2, x equals 2 times y minus 4 squared minus 6. Starting at the bottom over here, I got to get rid of any addition and subtraction. So I'm going to add 6. So I've got x plus 6 equals 2 times y minus 4 squared. Next thing I need to get rid of, multiplication or division. So I got to get rid of that 2. So I'm left with x plus 6 all divided by 2. People often skip steps on these and think that's okay because they're doing it just fine, and then they end up getting the wrong answer because they skip steps. Next thing I need to undo is the exponents. My exponent is 2, so to get the to inverse that, I do the square root. When I square root both sides, I square root everything over there. A lot of people have a tendency to write this as like x plus 6 over 2. These two things are not equal. So when you square root, you have to square root everything that's there and make it clear that's what you're doing. So what I'm left with on this side is y minus 4 equals the square root, running out of room, x plus 6 over 2. So I'm going to end up erasing this anyway. So I'm going to add 4. So I've got the square root of x plus 6 divided by 2 plus 4 equals y. And that, once again, is my inverse equation. So I'm going to write that off to the side. F negative 1 of x, that indicates that it's my inverse, is the square root of x plus 6 divided by 2 plus 4. This situation, all of this, is a really good example of how just writing down the example on your notes is not going to be super duper helpful. I guess I didn't need to erase that high. Anyway, the next thing you need to do, and this is where you should also, again, write down the steps. You can verify in 2 ways. The highly proficient method was to take your equation, and substitute your inverse in for x. If that's the method you want to use, go for it. I don't care which way you do it for this. I'm only going to show you the subbing in a number. So if you're squaring something, you want to pick a number that's bigger than 4. And I'm not going to get into explaining why, but it has to do with extraneous solution stuff. So I'm going to go ahead and do 6. So I'm going to start with f of 6. 2, and that can be any number. It's just some numbers work better than others. So 6 minus 4 squared minus 6. 6 minus 4 is 2. And by the way, you have to show all of your steps for the verification piece. 2 squared is 4. Otherwise, you're not really verifying. You're just saying, yes, I know what the pattern should be, and I'm not actually checking that this is working. 2 times 4 is 8, minus 6 equals 2. Once you get that, you're putting that in for x into your inverse. So I have f negative 1 of 2. So that's going there. Square root of 2 plus 6 divided by 2 plus 4. Once again, show all my steps. If you plug the equation, the inverse into the equation, that's fine, but you have to show your stuff step by step. You can't just scratch everything out. So this equals the square root of 8 divided by 2 plus 4 equals the square root of 4. That's a bad square root. Plus 4, which equals 2 plus 4, which hopefully you know equals 6. So this number that you started with should be the number that you come out with after you do all that substituting. So this is where it's good to write words in your notes, such as pick a value for x, plug it into your equation, what you get out of that, plug into your inverse, or vice versa. You can go either way. And your first and last values for x should match. So that is inverses. So that was Unit 6. Oh, just kidding. There was a lot more to Unit 6. That was the first part of Unit 6. Oh, this is so long. Okay, rebasing. This has to do with recognizing that 6 and 216 can both be written with the same base. So 6 is not anything squared or anything cubed. It's just 6. So we can only take 216 down. So we want to think about this. So 6 squared equals 36. 6 to the third, ta-da, equals 216. So we can rewrite 216 as 6 to the third. So I've got 6 to the 5x equals 6 to the third instead of 216 to the power of 2x plus 3. Whenever we take a power to another power, we multiply those two exponents, which means this is going to be 6x plus 9. Don't forget to distribute on that. If we have the same base and those are equal, then we know the exponents themselves have to be equal as well. So we just set the exponents equal to each other once our bases are the same. Oh my gosh, this video is forever long. Minus 6x from both sides. We've got negative 1x equals 9. Divide both sides by negative 1. And we've got x equals negative 9. All right. Writing exponential equations. This one was one of the more difficult ones. The method I'm going to show you will work every time with this. So, exponential equations have the form y equals ab to the x. Indicates that you're multiplying by something to get from one y value to the next, as opposed to adding or subtracting in linear equations. So, what we're going to do is set up a system of equations. It's the a and b that we don't know. We do know our x's and y's. I'm going to take the bigger exponent, make sure that one's on top. So I'm going to have 729 for my y equals ab to the 6th. I'm going to divide that by 45 equals ab to the 2nd. I want the bigger exponent on top so that I have a positive exponent when I'm done. First thing that gets eliminated, a divided by a is 1. So 729 divided by 45 is a number that I can't think of off the top of my head, so I'm getting my calculator out. 16.2. b to the 6th divided by b to the 2nd is b to the 4th. So I'm going to 4th root that, or put it to the power of 1/4. So I have b equals, pause again. Okay, so that gives me 2.0062. I'm going to go ahead and round that to 2. So I've got a b value of 2. I don't know my a value. So what I'm going to do is pick one of these equations. It doesn't really matter which one. Either one will work. I'm going to go ahead and use the top one. 729 equals a, which I don't know, times 2 to the 6th. So 2 to the power of 6 is 64. So 729 equals a times 64. Divide by 64. Is 11.390625, so I'm going to round that to 11.4. If you use the 45 one, you're going to have a slightly different answer, and that's fine. So then you need to write your actual equation, which is y equals, a is 11.4, b is 2 to the x. Now, if you have various pieces of information here, if you know the b value because your numbers are closer together, or you know the a value because this is 0, you don't have to do all this, but this will work anytime. All right. Logs. The inverse of exponentials. So, things you need to have in your notes. Log base b of a equals x can be written as b to the power of x equals a. Now, thing to remember about this, it is not the letter itself that matters, it's the position. The base here is the little number between the log and the big number. That becomes the base here. These two are in the same position. Whatever's on the other side of the equal sign is your exponent. And the big number here is your number over here. So we're writing this in log form. Sorry, in exponential form. That's the only thing we're doing here. 2 to the x equals 16. That's the exponential form. X to the 2nd equals 13. 5 to the 4th equals x. That's all you have to do for that part. When it came to solving this, a lot of people got into the stuff of like thinking they needed to use logs to solve this. This is the only one you would need to use a log to solve, and you didn't really need to that much. But knowing when to actually use a log when you don't know your exponent, as opposed to using a root or just doing the math, is an important skill to have, but not one that you have to have on the final for this part anyway. Okay, so first step, like anything else, make sure you have the difficult part alone. So in this case, it's the base and the exponent. You want to get that part alone. So we're going to use, shockingly, the inverse operations backwards again. So I need to get rid of that 6. So I got 4 times 3 to the x equals 15. Get rid of the 4 by dividing. So I've got 3 to the x equals something. 3.75. It's late. I apologize. Okay, so now I need to solve for an exponent, and it's not something that's easy enough for me to just figure out. So I need 2 parts here. I need that thing I just did, b to the x equals a. I need to be able to go in between those. So currently in exponential form, 3 is my base, so this would be written as log base 3. Remember, it's 3, or the base to whatever is over on the other side of the equal sign. So 3 to the 7.5. Sorry, 3.75. Goodness gracious. And that equals x. So I've got that 3 to the x equals 3.75. Obviously, you don't have to have all of those arrows there, but you need to do the rewrite. When you're solving using logs, it's rewrite, rewrite, put in the calculator. So the second rewrite for this is the change of base rule, which says that log base b of a is equal to log of a over log of b. Again, not the number or the letter that matters, but the big number goes on top, the little base goes on the bottom. And this is just so we can put this in the calculator as log of 3.75 over log of 3. Parentheses will automatically pop up here. Make sure you close them before you put in log of 3. And that gives you something else I don't remember. Hang on. All right, that one gives you 1.2 and change. There's quite a lot more to it. All right, so that is that part. And make sure you have that stuff in your notes if you don't remember it. These next parts, I am not going to go over. One, because this video is horrifyingly long. I'm going to talk about them briefly. So this part is going to be a totally separate part of the test. That's just going to be the blank unit circle. Here, finding the values in exact terms. That is going up here, recognizing your x's are cosine, your y's are sine, and your tangent is sine over cosine. If you're not familiar with that and you would like further explanation on it, go to the video for the Unit 7 review, because that has all that stuff in it, but I don't want to talk about it again. I am going to mention one thing here. Make sure that you can use the formulas for these, not just the degree, not just the unit circle. You need to be able to use the conversion. So like 2 pi over 3, if you're actually converting that using the formula, you're going to multiply it by 180 over pi. So that's going to equal 360, 2 times 180, pi over 3 pi. Pi's can divide out. 360 divided by 3 is 120, and that's degrees. The opposite direction, if I've got 300 degrees, I'm going to multiply that by pi over 180. So I've got 300 pi over 180, and I need to reduce 300 over 180. The first things I can get rid of are the zeros, so I've got 30 pi over 18. 30 and 18 are both divisible by 6, so 30 divided by 6 is 5 pi, and then 18 divided by 6 is 3, so this is 5 pi over 3. So this is why you need to be able to use both of those conversions. You're going to have something on the test that will not be on your unit circle. You have to actually just do the conversion. So again, if you need more help with, please make sure that you go to the video for the Unit 7 review. I just don't want to do the whole thing because this video is horrifyingly long already. So make sure you know what you can use. Make sure you have your notes ready. Make sure you have instructions on those notes, not just examples. And good luck. Bye-bye.